I'll take you through a very short tutorial for how to do the finite element analysis using the SolidWorks. Actually, the SolidWorks is quite good, but from the academic point of view, the answers is going to be much better as quality. But however, the example that covered in the previous video you can find here, and we're going to see them through the tutorial tomorrow, is going to be based on these SolidWorks parts. You can see that Terry actually gave us two parts. One of them is going to be in the SI unit, the other one is the original unit or the IP unit that's available in the box. Here are some of the chart for the Moore circle and the yield criteria with the fatal chart problems with the solutions given as video file, and that's actually what's covered in the third video for the tutorial solution that will be available for you very soon. So I downloaded these two parts and I opened the SI unit 1 in the SolidWorks, and we're going to make the basic study that we have on the SolidWorks, in the tutorial section. So here you can see that the material is not specified, and this is something very important. So again, to specify the material, basically I think that the material that we have here, which is the 1430, is not available here. So we will try to create the material if it's not available. So the example, once again, I'm looking at the other screen here. The other screen say that, yep, I got this one here. Okay, and I'll bring it to your screen in a moment. Okay, just give me 1 second, please. My computer running quite slow because I'm doing recording. Anyway, so the material that we have had the ultimate tensile stress of 703 megapascal, and I got this one here. Okay, so the examples say that we 1340 annealed steel has been chosen, and the ultimate tensile stress is 703 megapascal, and the yield stress is given as 434 megapascal. So now we are going to create this material because it's not available. So we go down. Actually, I made it earlier as the metal here, but anyway, I'm going to repeat for you the process of making that. So I'm going to delete this one, and I will delete that. Okay, and I'm going to delete this folder as well. Delete. Okay, so to create new material, if you don't have it in the on the list, first get the nearest one to it. And so we're talking about annealed metal, and that will be the nearest steel annealed one. So what we're going to do is I'm going to copy that, and then I'm going to go to here and right click and make a new category. And for this new category, I'm going to write down metals. Okay, and this will be okay. And within the metal, right click, and I'm going to paste the one that I copied, which is the 4130 steel annealed. Click on that, and I can change the name here to be 1340. Okay, and by clicking anywhere, this name will be saved, as you can see here. No. Let me check if I can change this one. Doesn't matter. Now we are going to change some of the parameters here. So that's the name here. Okay, and mainly we are going to change the tensile strength, which is 703, and we're going to change this one by the 434. Okay, just don't forget to apply. Okay, the appearance of the material is going to be different than the existing appearance. Would you like to link display? Yes. Okay, now we got the new material has been identified for the item. Close. Now the whole thing has been identified with this material. Now do the simulation process. Once again, if you ever ask yourself about these steps, if you go to the simulation, this will help me to make studies. So I'm going to click study. It's going to be stopped. Anyway, we shall wait for that to stop. Now we're going to repeat once again. Okay, done. I'm going to, I don't like to restart SolidWorks from here. I just want to send the report. Yep, so go to here. Basically, this stuff should be saved for us. Sorry, that should be actually a shorter video. Skip that part. Okay. Okay, so just open the same file. I have it here. That's a different one. I have too many files. I need to rearrange that one day. Where's my folder? Can't see on the screen. Just give me 1 second. Okay, and the week 2. So hopefully that the material has been saved, otherwise we need to repeat the same step. Material is not specified. Edit the material. Simulation. We will start study. Okay, so just take that you are going to choose a static study. Okay. Now you can see that we have multiple parts. You can see that actually the wall at the back is disabled on purpose, and we're going to start the steps first by adding the fixtures, because this part should be fixed at that end. So we're going to click on that face, and we're going to add the fixture. Right click and fix geometry. Okay, so this will make it fixed. That's it. Just click OK. Now we have the force of 1000 Newton, which is fixed at the end of this part here. So click on that face, and then we're going to add the external load. We're going to add the force. On that face, you can see that it's normal to the face. We don't want them to be normal. We want them to be parallel. So we can change that. Okay, and by doing the selected direction. So you can see if I get to click on this one, this will go to the inside. If I click on that direction, this edge is going to take them up. We want them to be down, so just simply reverse the direction. Now they are going down. That's it. Okay, tick OK. Now the next step is going to be about the mesh. Usually the mesh is dividing the CAD model to a finite elements. That's what I call the finite element analysis. Right click, and we're going to create the mesh. So you can see that we have mesh density finer, that's mean more number, coarser, less number. The default is going to be in the middle. So I'm going to reset that. Okay. I'm going to generate that. You can change some of the mesh parameters here. It's up to you. Okay, what will be the size of the mesh? Remember something, that we already have some what we call the critical analysis for the number of the mesh we have. Usually the more smaller mesh is going to be better in results, but to a certain level. That's mean at certain level you're only going to slow down your analysis, but the result is going to be the same. Although we're going to accept that now because we just want to show you the thing is meshing the things, and that's the part. So I'm going to save this file now because it may crash again. Okay, so yep, you can see that it's been dividing the mesh, the part into the elements, and each one of these elements is what you actually learned in the previous subject about how we are going to get the forces divided on the part. Now, the quality of the mesh can be changed at any time that you want. Okay, edit definition, do the setting, and so on. Now, we need to have the results. So how am I supposed to do that? Simply search for run this simulation or run this study. Just click on it. Now it's do the running, and you will find that we have some colors. Okay. So you can read here that something called the von Mises, the type of the analysis is the von Mises. Actually, this is not too much similar to the one we're supposed to have. Maybe I went wrong somewhere, but we're talking about the point A, which is going to be here. And as you remember that as we go further, we're going to get less stress on the part. That's for the displacement. Okay, show the displacement. So the maximum displacement, of course, is going to be at the end. You can see that this part actually bended. Now show for the strain, and that's how we're going to have the high strain going to be in this area, the minimum is going to be at that area. That's the reader for the amount of strain we're going to have. So basically, according to the calculation, you can see that these figures are quite higher than the one has been calculated, and we're going to explain why during the tutorial session. Okay, of course, there are many videos I can share with you that will help you to do the work in a more efficient way and more advanced way, and we can also show you some examples for the FEA